Hello, everyone, and thank you for joining us this afternoon for the seventh week of the Rugby Research and Injury Prevention Group 2025 Analytics Series. So we'll begin our presentations with our first intern, who is Gabriel, a sophomore from Adelphi University. Gabe will be presenting on SPSS versus Stata Top 7 useful differences that you need to know. Gabe, when you're ready, may you please share your screen.
Thank you for that introduction. I'll share my screen right now. Just want to make sure everybody can see. Good. All right, cool. So good morning, everybody. Thank you, Violet, for introducing me. My name is Gabriel. Today I'm going to be going over SPSS and STATA. These are two different softwares that they use in data analysis and data collection, and just a few differences that I think you should know and actual real-life applications within rugby research. So let's begin. Let's go over what is SPSS. SPSS stands for Statistical Package for the Social Sciences. It was created in 1968, and now it's owned by IBM, which is a big company. It's designed for analyzing data, especially in social sciences, health, education, global public health, and things in that area. So you could think of it as a more advanced Excel, aimed towards statistics and large data sets. What's data? So Stata is another software which is also for analyzing data, and it was launched in 1985. This one is more geared towards economics, data science, and some medical research. It's not as much as in social sciences as the other one is. This one offers both menu-driven and command line interface. So what that means is you could have your data and you put a command like, let's say, get comparison of all the differences in gender or how many differences in males versus females. So this helps make it flexible for beginners and advanced users, even though there might be a bit of a learning curve in initially using the command line interface. But this is great for serious number crunching and building research models that will use repetitive commands. So looking at complexity, you can see the user interface for both of them. SPSS is on the left and Stata is on the right. As you can see, SPSS, it looks a bit more simpler. It handles very complex data, and it makes it look simple with the user-friendly, just click, menus, and the different widgets that they have. Stata, on the other hand, it's a bit less friendly. That doesn't mean that's bad, but it might just be a bit more complex because it's for big, complex problems if you only use the menus. But if you're comfortable with commands, like what you would do right here, you could put in like what I said before to get you the differences in gender or differences in ages, and it'll make you a table just like this with the results that you asked it for. Now, in regards to analysis, SPSS is built for large, complex statistical analysis, and it could do multivariable tests, survey analysis, etc. So it's big for maybe the research that we're doing. But Stata, it handles standard analysis very well, maybe more complex, just number crunching, things like that. It has strong tools for advanced modeling, especially in economics and epidemiology. So injuries, diseases, things like that. Now, application. So what type of fields use these different softwares and interfaces? SPSS is more used in psychology, sociology, health sciences, education, and some government research. Stata, on the other hand, is preferred in economics and metrics in that area, epidemiology, and political science. If we look at a real-world example, the CDC uses SPSS for health surveys, and the World Bank, economists, they tend to use Stata. Now, in regards to benefits, they each have their own strengths and weaknesses. So SPSS, like I said before, it's a friendlier interface, and it could give you quick charts, tables, and visual aids that can help you understand your data a bit better. SPSS could directly generate the outputs into reports that are easy to read. The Stata, what's nice about this is that the command line, it helps automate the things that you want to do. So it's great for reproducing research. Let's say we have a big bundle of research and we just want to do the same thing we did before. We just put in the same command and it'll give us the similar processing of the data analyzed. Now for utility, SPSS, it feels like an advanced spreadsheet. Just think like a more advanced Excel. It's good for managing and cleaning up large and somewhat messy data sets like what we have with the RDC stuff that we work with. Now, Stata, it shines in research where you need lots of control and you want to automate the analysis step. And that's usually done, like I said before, with the command line. In regards to statistical analysis, SPSS is slightly stronger for everyday statistics, basics tests, survey analysis, etc. And Stata is still very strong, but it's not what it was exactly built for. It's more for focus on building models, regressions, and simulations. In regards to development, SPSS is often used for building and testing models as part of a big project or project development. And Stata is a bit more popular in academic research for building new methods, like I said, especially in the economics and epidemiology area. So when would we use Stata and SPSS? These are just made up scenarios that I think could help us understand how we could use these different tools for the best results. So suppose that we're a team of researchers and we surveyed 500 rugby players about injury types, recovery times, training habits, and mental health over this last season. And you want to find different patterns, like whether players recover with like whether players who report more intense training have more injuries, or if certain periods or if certain positions have longer recovery periods. SPSS would be ideal for this because here we're managing and analyzing a large survey data set. It's 500 rugby players. We're getting so many different variables collected. It's also ideal because we're running descriptive statistics, cross-apps, and we can produce clear visual reports to share with coaches or medical teams, which helps us break down this data a lot easier than just giving a bunch of numbers. And the third benefit is similar to the second one. It helps create those quick charts that help us show the data. So which position has the most concussions, and we can get a graph. Or are certain training routines linked to faster injury recovery? Now, let's look at what would we use data for. Instead of using it for that large data, now imagine you're analyzing video injury data from every game in the season for 3 different rugby leagues. And so we want to run advanced statistical models to see if changes in tackle technique rules over time actually reduce concussion rates. So what that means is in 2011, the tackling rules were different than they are now. So did they make it safer for concussion rates? And we would account for differences between leagues and the differences in the years. Stata is better for this because it handles the complex longitudinal data sets, such as the repeated measures for the same teams across seasons. The second benefit is that running logistic regressions, it can run these regressions to see if no rules predict a drop in head injuries, adjusting for the age, position, league, or year. And the third benefit is that it's automating analysis to produce large amounts of coded video or injury data, and it can generate reproducible results and tables for publication. So what that means in short is we could keep reproducing the same, process and get results and tables that are of high enough level to show out to other researchers and say, hey, this is our process. You could use this to analyze your own research as well. The next thing I want to talk about is industry practices. So in sports epidemiology and rugby research and sports research and the different things that we might encounter in our careers, you'll see that SPSS is used for descriptive reports, survey analysis, and quick stats for teams or governing bodies. On the other hand, data is used for published research, advanced models, or when working with large data sets. Imagine national or multi-season injury databases. Major rugby injury studies, like those in the BJSM or sports medicine journals, they often mention using Stata for their advanced regression analysis, especially when tracking changes over times or comparing groups. So, like I said before, there are groups with pre-2011 and after when the rule changes happened. These are my references. If anybody has any questions, please feel free to ask. But thank you guys for listening.
Gabe, thank you for that wonderful presentation. I just want to make a comment. I really liked how you used examples and how to use when to use Stata and when to use SPSS. I think that helped get a better understanding of what these two really are and how they differentiate. And yeah, I just really liked how you used two examples that were similar but different at the same time. Does anyone else have any comments or questions that they'd like to ask? Okay, so we'll then move on to our next presentation. Our next presenter will be Asha. She is a first year from Columbia University, and Asha will be presenting on the descriptive statistics and standard scores. Asha, when you're ready, may you please share your screen?
Thank you for the introduction. Can you guys see my screen? Okay, perfect. Hi, good afternoon, everyone. My name is Asha Gadraj, and I will be going over descriptive statistics and standard scores. And so what exactly are descriptive statistics? Essentially, they're measures used to analyze a smaller data sample and try to get a picture of it. So this is good for smaller populations and describes specific measures that allow you to really get a grasp for what exactly you're looking for when it comes to the data. Now, this is very different from inferential statistics. This is used to test hypotheses and involved with larger databases. As the name inferential suggests, it's more of trying to use statistics to get a generalization of data. And so when we're doing basic descriptive statistics, it's just more of a factual picture that we can begin to understand the data we collected. And there are a few different ways that we do this and a few different things that we record. The first being averages, and this might sound a little counterintuitive, as in why is averages in this presentation? But really, it's a really good way to kind of get a grasp for the range of values that you have and what average values could be. So the most common way, as most of you know, is just take the mean, which is add all the values and divide by the total. However, when considering averages in different data sets, we might want to consider the median as an alternative instead, as it's not as skewed to one side. Another way is to linearize the data and calculate the mean. So depending on what data collected, the situation can vary. So for example, one exception that I put was pH. So say you want to find out the average pH of a sample of someone's blood. Now, pH is not on a linear scale. And so when we're trying to find the average of that, we can't simply just add up the pHs and then divide. That's not the way a pH works. So then you might want to consider the median. You might want to linearize that or just consider the median when you're doing different scenarios. So it can change. The next thing that we do when we're doing descriptive statistics is measures of central tendency. So this is just a single value that attempts to describe a set of data by identifying a central position. So on this image here to the right, this is a normal distribution. And so here the mode, the median, and the mean happen to be the same value, which is a value close to the middle. Now, means are usually calculated with the decimal points. However, these measures of central tendencies are not as useful for a whole number of values. So, for example, if you want to measure like the number of blood cells, the number of patients, you can't exactly divide that into subparts. So, in that case, a mode or median would be more useful. And as always, appropriation is important. So, when we're looking at this other distribution here, we see it's skewed towards the right, meaning that the tail here is longer than the actual majority. So this is why we say it's skewed towards the right. But notice how the mode, median, and mean are all at different values. And so you kind of have to appropriate what exact value you want to use when you're looking at your measure of central tendency. The next thing we look at is spread. Essentially, how far out is the data from one another? And this refers to range, quartiles, and variation. Essentially, how extensive are the values? So I have an example here on the right, which is job satisfaction ratings of three groups. As you can see, the spread for all three, despite having the same central tendency, around 50, as you can see here as it's down the middle. Notice how the spread is different. So for the blue one, it's closer together, and for the yellow and green, they get farther and farther apart. And so when we want to measure spread, we tend to use standard deviation, which is essentially as you can see from the formula here, the number of data points, each of the values, and the mean. So it's more of how far is the data from the mean, or in this case, the central tendency point. The next thing we look at are standard scores, and this is in relation to a curve. Um, as many of you probably know, if you've taken any standardized tests, the curve could vary with each test. For example, I use the SAT as an example. A 1350 on a June SAT may be more difficult to achieve than a 1400 in March. And just to really illustrate this point, I have this example here on the right. We can pretend that these are two different test curves. So for example, um, say this is you, and you scored for the higher end of the curve, which is pretty good. This is above the 50% performance. and you essentially excelled in that test curve. However, for this next test, while your friend did better than you, that doesn't necessarily mean that they took advantage of the curve. In other words, they still performed below 50%, as you can see from the central tendency. So really, curves, when we want to quantify it, we use t-tests, which really analyzes the different means of data, as you can see here from the formula. And this measures how many standard deviations are above, below the mean. And then we have our normal distribution curve. So this curve appears in all sorts of natural phenomena like weight or height. It's usually a symmetrical distribution, as you can see here, and this curve is often used for probability. So when we go ahead and we take a look at what we're looking at here exactly, these values basically refer to standard deviations. So when we're looking at this curve, you can see that between the first two, like the ones here, this accounts for 68% of the data points. And as we get further and further, we tend to analyze more so from 2 to 2, as this covers the majority or bulk of the data. These are my references. And are there any questions?
Yes, thank you, Asha, for that great, excellent presentation. Um, does anyone have any questions, like Asha said, or comments that they would like to add? And if not, that will conclude our call for today. Thank you, everyone who joined us for our Rugby Research and Injury Prevention Group Analytics series.